During electrolysis of molten sodium chloride, the time required to produce 0.1 mole chlorine gas using a current 3 ampere. That is the question. How much time is required in minutes? That is what asking. So how can you do that? See, 1 mole chlorine to get 1 mole chlorine, all of you know it is 2 equivalent. You need 2 Faraday. 2 Faraday means 2 into 96,500 coulombs. This is required for getting 1 mole chlorine. So for getting 0.1 mole chlorine, how much required? 0.1 mole chlorine gas, how much required? It will be, how much? 0.1 into 2 into 96,500 coulombs. This much is required. And this is equal to I into T. I into T. And what is I given? 3 ampere. I given 3 ampere. And time T in seconds. So by equating this with this, you are able to find out the time in seconds. Dividing with 60, you will get time in minutes. That's all. Over. So 1 mole chlorine to get, you need 2 Faraday. See, chlorine, you know it is Cl minus. So N factor is 1. When we are talking about Cl2, it is 2 chloride. So N factor is 2. 1 mole of any matter, you need N Faraday. 1 mole of any substance. 1 mole of any substance, you need N Faraday, where N is the N factor. N factor for chlorine, 1 chlorine, 1, 2 chlorine, 2. Right? Valency factor. We are talking about chlorine gas. Chlorine gas is Cl2. So 1 mole chlorine, you need 2 Faraday. 1 mole sodium, you need 1 Faraday. 1 mole zinc, you need 2 Faraday. 1 mole calcium, you need 2 Faraday. 1 mole aluminium, you need 3 Faraday. These are all N factors. Once you know that, over. So 1 mole, 2 Faraday, 0.1 mole, 0.1 into 2 Faraday, and that is equated with I into T. You know, Q is equal to, this is the quantity of electricity, Q. Q is equal to I into T. I given, you calculate time in minutes, not in seconds. So here you will get the time in seconds, divided by 60, you will get the time in minutes. Clear? Right. So what will be the answer? Check out the answer. It is coming somewhat 6433.33 seconds. If you verify, you can get that. Divided by 60, it will be 107.22 minutes, and the close figure will be option 4. Option 4 obtained as the close figure 110 minutes. I think it is clear.